Yes, good afternoon, ladies and gentlemen. Yes, I have been a long time in the industry, and I'm older than I look, actually. But yeah, so I originally started off in the engineering area, and I moved into the operational service area. So my talk today is, in fact, a little bit to do with engineering and a little bit to do with operational management. It's actually matching capacity to your revenue potential. Probably most network operators would realise that their networks are probably 40 to 50% efficient. So you really need to improve that to a higher level, and now the tools and the facilities are available to in fact do that. Is that the wrong button? Got it. It's the right one. Yep, sorry. Okay, so what I'll be talking about today is giving you a little bit of a picture of global trends, and you probably have been blown away with all the global trends that you've heard over the last few days. I'll probably reinforce some of that stuff, in particular then go into what's been done about that in terms of the network architectures. Looking at the architectures that are coming out, there's obviously a lot of challenges that we're faced with to manage that network or to make use of that network. Challenges in respect of making sure that we operate it correctly, but also a lot of very much opportunities to be able to use that network to be able to gain more revenues with the existing facilities that are available. In particular, I'll work on to what we call a HetNet solution. HetNet, of course, is just a short name for heterogeneous networks, and I'll come to explaining what that means. And finally, I'll just close off with one particular case, just to put a bit of credibility to some of the theory that I'm putting forward to you this afternoon. Okay, so you probably know now that you've probably all got a smartphone in this room, and in Indonesia there's got Blackberries, but that's pretty smart too. In most other countries you've got iPhones, and you've got Huawei phones, and you've got Samsung phones and the like, all of which are adding to the data loads. There's about 4 billion new smartphones, 10 billion new smartphone devices. That's all going across the network at various places. So what we've done to date is to provide certain layers of networks. Those layers can cover a certain average traffic. But of course you're going to get hotspots at places, and that leads to, of course, your VIP complaints. And another acronym in telecommunications, very annoyed person, VAP, also is coming to the fore. What we've got to do is get rid of the VAP acronym altogether and focus on making sure we are proactive about our VIP customers. You can see the layers there are both in urban, suburban and rural, and there are different layers that are applied to each one. In general, you end up with an imbalance if you don't plan it right. Now, in the old days, we had a single layer network, such as GSM, mobile networks. We might have supplemented that with a bit of fixed network as well. If you look at the applications, you can see where all that data is coming from. And you can see where Asia sits in terms of North America, for example. In North America, one of the biggest growing trends is in video streaming. Asia's somewhat behind that at the present moment. We haven't got quite the video streaming. Video streaming basically means to us operators, it means that we've got to cater for more megabits. At the moment, we can get away with about 1 megabits, which covers the average data speeds down to all the terminals. Once you start video streaming, you'll probably know that you'll probably need something like 1.9 to 2 megabits minimum to get a reasonable data transfer for video streaming. The graph up there gives you a bit of an indication of each in particular level of traffic that you have on the different services. And of course the focus nowadays is not on networks, it's on services. We're making sure that the customer is getting delivery of these services. So let's move on a little bit. So we've got a lot of capabilities nowadays. You'll see downstairs in the exhibitions and up here, you'll see a lot of new products. Most of you will be aware that you've had a GSM macro layer, you've had a UMTS macro layer. You also have micros base stations coming in. You've got small cells and you've got big cells. You've got a situation where if you have a VIP complaint, well, invariably what you do is you send out a drive test team, you check what the complaint's all about, and you say, yes, the customer has got a problem on this location. So what do? Oh, we'll use a femtose cell, or we'll use a small cell and we'll cover his problem, or her problem, or that corporation's problem. Then, of course, you put the thing in and it starts to work a little bit, but you've got to match and optimise the traffic between the higher layer and the lower layer. You've done a reasonable job, but it's all manually done. It's all done with a lot of time and a lot of effort and a lot of operational effort. And of course, you probably haven't optimised it across the other parts of the network. So your efficiency is probably about 40–50% in the utilisation of those facilities on the macro and micro layers. Notwithstanding that, the infrastructures that are available today are giving you something like 500 times the capacity that you got with multi-layer networks, as opposed to 1 to 5x on the single layer networks and something like 10 to 50x where you've got a dual layer network. Most operators nowadays are making use of those facilities, but they still haven't capitalised on the advantage, the opportunities that you can take by utilising this equipment effectively. Okay, so let's have a look at the challenges there. So what we've got is a multi-layer network. There's a lot of potential here to actually get this exactly right. But remember, a microcell or a small cell is generally very, very accurate to a certain degree, a certain area, whereas a macro cell covers a larger distance. Absolute difference in utilisation. Added to that, you've got things like Wi-Fi terminals, which in fact are even more accurate again, very selective into a small residential home. So a different service capability. They also have different speeds available to each one. They've got different characteristics. So you will find a Wi-Fi terminal was probably more capable of, if it's working, and I hear a speaker saying earlier that they don't work very often, if it's working correctly, you've got enormous speeds for download. On the other hand, you've got a GSM network that's a legacy network that you already have there. You'd like to use the capacity, but that only has a capacity of very small. But it's good enough for uplink, so you can utilise that for uplink. Now these networks in the future will have plug and play. So effectively you'll be able to put a microcell in, and that microcell will look at the rest of the network and actually optimise itself within that network. But that's not quite there yet. That's probably 2 to 3 years off. You will see downstairs one particular product that already does that in the way of LTE and a macro layer. It will actually balance itself, and in fact, even better than that, the two cells will operate in conjunction with each other, whereby the traffic that's going from the user through to the network is shared between the two base stations. You probably know at the present moment to send data down or up in a stream, you have to hand over from one cell to another one. Each cell handles its own traffic. In the new area, each of these cells will in fact be able to handle traffic consecutively on the one user stream. Not yet, but that's where it's going. So, if you look at the various levels and what you want to get out of this, you really need to look at the impacts of these new products and the equipment. You have the potential now, if you can get the accuracy there, to actually allocate resources specifically to 3D coordinates in a network. Not just at a cell basis, but actually down to a 50-metre radius. You have the potential here to have handovers organised appropriately to carry the correct amount of traffic, the right amount of traffic, the different services required for the user. And finally, when you've got all this information, you can actually get the monitoring of that network at a 50-metre radius to give you the sort of marketing information which will enable you to not only adjust your revenues and optimise your services, but of course you can also optimise your costs, because you can optimise the network and get a lot more efficiency out of a current network. In the Asian market, there's probably more potential than let's say, some of the developed markets in Europe and North America. It's much more difficult to take a GSM network that's been there for many years and introduce the new technology which will enable it to adjust itself. Whereas in the new markets in Asia, we see a trend whereby they tend to adopt these technologies much more rapidly. It's a lot easier when you're, particularly for greenfields networks, to establish this from the onset and have a very, very efficient network. Okay, let's look at what Huawei is offering in this respect. Up to now, I've just given you a bit of a picture where everything's going and some of the challenges with heterogeneous networks, which is applicable across the board. Huawei has identified that this is an issue, an opportunity, I should say, not so much an issue, it's an opportunity for us to get something out there which will give a better performing network without any major influx of capital investment. Certainly you need to put some investment in, but it's not a change of networks as many operators would believe. We call it the HetNet service solution, of course, because that's an obvious. Okay, so what have we got to work with? We've got active antennas, we've got macros, we've got carrier-grade Wi-Fis, and in the long term, you've even got the Wi-Fis that exist out there with customers, but that, of course, will require a little bit of politics and a little bit of interworking with the users themselves. In the electricity industry, in fact, users can actually share electricity and actually put electricity back into the grid. In the long-term telecommunications network, there's no reason why a Wi-Fi terminal that you own can't be shared between other people, and maybe you get some return on that as well. That's a concept. Okay, you've got the micro layer as well. In terms of products, I've listed a few of the Huawei products here. Now, obviously, every supplier has their own products. But basically, the products are going from macro-type large base stations down to individual base stations which may be sitting on the wall, which are completely incognito. You've also got such things as active antennas, which actually follow your terminals around and make it much more efficient, much more capacity available. And of course, you've got Wi-Fi, which is both the existing Wi-Fi, which is residential customers will now buy, and you will also have carrier-grade Wi-Fi introduced by the operators themselves. So the solution we have is twofold. First off, you need to be able to monitor. In any solution, you need to be able to get the information that you require to design that network. A lot of inputs can come from the existing facilities that we have, which includes the databases that exist in operators in terms of the quality and capacity that you've got there now, and planned capacity, the resource allocations, the neighbour lists that you already got in there all are planned. You've got your tariff and packaging plans, etc., and service types that you've actually introduced into your network. But in addition to that, you need to have other information to get down to the accuracy of 50 metres, and you need to also identify the different service types that customers do require. That means that you no longer start to look at boxes and counters on boxes for service types, which is actually only a counter on the equipment itself, but you have to put probes into the data streams themselves to look at what data is being transferred from the user. You have to look at the signaling to determine what sort of services that they're actually requesting and how often they get success rates, how often they get failure rates. And that signaling will also give you details of terminals. There's an enormous amount of information you can collect, providing that you're prepared to put those probes in on the data streams themselves. Having collected that information, that can all go into a tool which then designs your network. That network design is based on a three-dimensional design, and the output of which will give you not just the design, but also your marketing strategy going forward, because it gives you a wealth of information about your network compared to the service offerings that your customers require. And finally, it gives you an additional advantage, which is traffic management. So in real time, you should be able to measure the service requirements at each particular location to a 50-metre point and adjust that traffic and optimise that traffic across the various layers of base stations, the multi-dimension, both in a horizontal plane as well as a vertical plane. A little bit more pictures on what the solution design is. One of the most important things in the design is getting the information input correct. It's no good having a fantastic tool if the data that you get is not correct. So the tools are most important, which is the bottom areas. Once you've got them into the tool, you then get your next two layers of your get your network successful, and of course that leads, once your network's successful, to an 80% or above success rate, efficiency rating, which means business success. Okay, just to give a couple of examples. We have in a number of instances actually done designs. In this particular instance, we did an exercise on a current network assessment, and we looked at GSM and UMTS and looked at the dispersion between the two. Prior to this exercise, each individual network was designed on its own accord. But of course, the operator particularly wanted to actually transfer as many customers from GSM to UMTS with the intention that they would expand only in UMTS and eventually get rid of the GSM network, in other words, a migration. So we worked on the raster plans of each area. We had three different raster plans for the different areas. We had the terminal distribution of those. We had a lot more information. We then produced a total raster plan for 3G, 2G interoperability, and we ended up with the following benefits below. We had an accurate map, basically, of the terminals, the traffic, and from both the network perspective and also as an overview across the whole network. The end result was we got a better experience for the customer, and we got much closer to the customer's actual user requirements to be able to design the network correctly. If you look at the old and the new, the old traditional approach was to do drive tests and over the whole area, and that was only done whenever you got a VIP complaint. The new approach is almost real-time traffic imbalance measurement to a 50-metre radius, giving you much more efficiency, much more accuracy. Another map of UMTS and 3G, yep, just to information. Another design that we've had put together. You can see the output of here is GSM, wireless LAN and UMTS networks, all working together to give you a balanced traffic. Not only can we design that and manage the network going forward, but of course this is also used for future planning. So the tools that we have in fact enable you to provide a full site determination, very accurate site determination, not only in a two-dimensional layer but in a three-dimensional layer. You can feed all this information back into the marketing, into your marketing strategy, which basically gives you all the user behaviour analysis, which obviously everyone realises is absolutely important. This information is available, it's just that operators to date haven't yet picked that up. We get a terminal analysis and we can see where all the terminals are going for smartphone, Blackberries, the new iPads, etc. that are coming in. And of course, most importantly, we also get a service bearer analysis to enable us to get our efficiency of the network, minimise our capex and utilise what facilities we already have in the network. And the last area I'd like to cover is PCC. Having done all this traffic analysis and being able to optimise the network, we can actually use the standards PCCC, which basically is policy, charging and control, whereby we can input this information back into the charging packages of the operator. So charging packages can be rearranged on a real-time basis to provide a changing traffic pattern. By changing charging patterns, you change the user behaviour, the users then change the traffic patterns. So you can actually give them free service at a certain time when your traffic is very low. You can give them very, very high cost services when you're congestion, or you look like you're going to get congestion. So, just as the last slide, because I've been told that I've got in my last bit, I just wanted to quickly put up on the screen that this is not all theory. This is in fact practice. In fact, this is an exercise in China in this particular case where universities, and universities are a very heavy user of high download speeds, etc. In this particular case, our modelling tools, etc., produced additional couple of base stations and optimise the whole of the network to give a very, very good user experience across the base layer, as well as in the university itself where we use Wi-Fi solutions. That will end the presentation. Of course, I'm happy to answer questions at this stage. Thank you.